No, it's difficult.
Well, just do it this way. Okay. So, I want to bring to you the case study, the example of the case study of Lake Scharmützelsee, which is the largest lake in the federal state of Brandenburg, and indeed one of the finest lakes in Germany. We have a research station there. I come from the Brandenburg Technical University. First, some basic data on the lake. It's 12 kilometers long, 2 kilometers wide, 30 meters deep at the deepest, and the hydraulic retention time is about 12 years. So this lake was under intensive pressure from sewage inflow beginning from the 1950s to 1990. There was a military hospital, military barracks and so on, and a huge amount of tourist facilities. With the German unification, it happens all within 1 or 2 years. This sewage imports was stopped rapidly, 1990-91. And what happened? It took about 13 years to see some effect with the phytoplankton. Although the phosphorus decreased all the time, but it's only since 2003 that we reached more or less mesotrophic conditions with second depths of 3 meters. So, three little posters here. Some more aspects. Phytoplankton. The main difference we see is that the blue-greens are not there anymore. So the community has changed. But this is, if you can see it, I have little leaflets down there if you want to have a closer look. This is the assessment for the Water Framework Directive based on phytoplankton. And what we see is that the lake is still a transition between good status and moderate status. So we haven't reached yet what we wanted. So we've looked at the other things like submerged macrophytes and the reed belt, and what we see is submerged macrophytes were abundant in the 1930s, we have records of that, and they totally disappeared in the 1980s. What we see now is they're coming back, and at the moment 24% of the lake is covered by submerged macrophytes again. But still, according to the assessment scheme for Water Framework Directive, it's still moderate and, due to the species composition. We've monitored the reed belt. The same picture, it died back virtually, but it comes back now. But we have done an aerial photograph and GPS study, and we see that only 54% of the lake shoreline is grown with reed, which is surprisingly normally all the shoreline would have some reed belt. This brings me to the final and most important part of my talk, which is shoreline protection. The reed belt is heavily fragmented, and this is because of two things more or less. We have the problem that there are plenty of landing stages, jetties, fortifications, beaches and so on. There's 304 landing stages, which is an average of 1 each 100 meters, and which results in a highly fragmented reed belt, as I said. The other thing is there's a high pressure of private and commercial construction close to the reed, close to the shoreline, right down to the shore, which is a common problem we have on lakes that are learned here, and which results in the shore structure damage and restricted public accessibility. So theoretically, we have different pressures on lake shores, being either direct or indirect. This results in the damage of the structure of the lake shore, which I mean the shore itself, including the littoral, so the reed belt and the submerged macrophytes. So, as a consequence of this impairment, you lose functions of the lake shore for the lake itself, which has two aspects. You're losing the reed or the lake shore habitat as a hotspot of biodiversity, and so important loss. On the other side, there are several feedback mechanisms on water quality. These are what we are concerned about. The point I'm making is the better the lakes get, the closer you get to the reference state. the more important these feedback mechanisms become. So, for Shelter Mützensee, we've concluded that to reach the trophic reference state requires an intact shore structure. Currently there's lake shore and lake management plan being worked out, and we as a university we're being asked about these jetties and beaches and so on. What impacts does it have on the lake water quality? Because this is the main important thing. How important is fragmentation? What's it about? So actually we don't know really. So I'm closing with two questions more or less to ask you or have discussion. Which degree of structural deterioration and habitat loss is acceptable for LA? And for me as a scientist, and for the questions we have now, what are the quantitative relations between different impacts of the lakeshore and functions of the lakeshore for the water quality? The summary I read from the paper. To summarize, lakeshore protection is not only important due to preservation of a valuable biodiverse habitat, but also due to various feedback mechanisms with water quality. Unfortunately, I think these are poorly understood and require some research and also some exchange of experiences. And if there's somebody around here who has the same problems in my discussion, I'm most happy to do this. There's some leaflets here with these 3 posters on it, and hoping to have some talks. Thanks.
Thank you very much.